Hello. Iron was being smelted in Britain from around 750 BC, and by 500 BC, iron had largely replaced bronze for tools and weapons. Ore was roasted and crumbled before smelting with charcoal in beehive-shaped clay hearths. Hand-operated bellows were used to raise the temperature sufficiently to create a bloom of iron and slag, which had to be repeatedly heated and hammered to produce workable metal. By the 16th century, water-powered bellows were delivering a blast of air to achieve higher temperatures in small furnaces, enabling slag to be tapped and molten metal run off into moulds to form ingots known as pigs. At the beginning of the 18th century, iron smelting remained a small-scale industry, largely centred on the Forest of Dean and the well-wooded Sussex Weald. Increasing demand created a shortage of charcoal. Experiments smelting with coal were tried, but too many impurities produced poor results. The technological breakthrough came from Abraham Darby, who transferred his experience of running a brass foundry in Bristol, during which he set up a laboratory to gain a better understanding of metallurgical processes and developed ideas for improving the efficiency of furnaces, to working with iron. In 1709, he started a brass and ironworks at Coalbrookdale in Shropshire, now part of Coalbrookdale Museum of Iron, a carefully chosen site on the River Severn with links to Bristol, an existing blast furnace, few neighbours to complain about the noxious processes, and a ready local supply of low sulphur coal suitable for coking to remove impurities. Darby redesigned the furnace and was soon producing coke-smelted iron of sufficient quality to produce thin but strong castings using sand moulds, a technique he had refined working with brass. Rather than one-off pieces, casting in moulds enabled mass production of small items such as cooking pots. Increased productivity and reduced costs delivered an immediate commercial advantage. Darby came from a Quaker family, and his venture at Coalbrookdale was largely financed by the Bristol Quaker community. A surprising number of the Industrial Revolution's entrepreneurial class came from nonconformist backgrounds. Iron merchant Sampson Lloyd, founder of Lloyd's Bank with John Taylor, was a Quaker. The Gurney textile and banking family from Norwich were also Quakers, as was agricultural machinery manufacturer Robert Ransom. Protestant dissenters, such as Unitarians, Baptists and members of the Society of Friends, faced with exclusion from many professions and from civil or military office, put their effort and energy into exploiting opportunities in commerce and trade. Quakers in particular came to dominate business, typically practiced with philanthropy. The Quaker Archives at Friends House in Euston Road, opposite Euston Railway Station, contains a handwritten code of commercial ethics. In 1698, Thomas Savery, an army officer from Cornwall, patented the first steam engine, designed to pump water from tin mines. Nicknamed the miner's friend, it had limited capacity and wasn't particularly dependable. Dartmouth ironmonger Thomas Newcomen, incidentally a Baptist, working in partnership with Savery to stay within patent restrictions, supplied the development that improved the machine's capability and reliability. In Savery's model, steam was condensed in a tank to create a vacuum and hydraulic pressure. Newcomen's advance was to condense steam above atmospheric pressure, creating a vacuum inside an open-topped cylinder that drew down a piston connected to a crossbeam. A new injection of steam and the weight of the mechanism returned the piston into position for the next stroke. To operate efficiently, Newcomen's design needed precision components, which, thanks to Abraham Darby's pioneering work with coke-smelted iron, was available from Coalbrookdale. The first Newcomen engine is believed to have been installed in 1712 at Conygree Colliery near Tipton in the Black Country. Over the next 2 decades, more than 100 Newcomen engines were built, enabling deeper mines and an increased supply of coal. At Coalbrookdale, the ironworks founded by Abraham Darby continued to grow, and new products including decorative ironwork were added to the company's output over time. Darby was succeeded in turn by his son, Abraham Darby the II, and grandson, Abraham Darby the III. In 1775, with industry in Coalbrookdale expanding, the idea of an iron bridge across the River Severn was proposed to replace a slow and unpredictable ferry. Abraham Darby III was commissioned to build the bridge. Finance was raised by selling shares, and the first large cast iron bridge in the world opened in 1781. At 200 feet in length, with a 59-foot clearance to allow for shipping, it was the largest cast iron structure of its time. With no precedent, construction techniques were based on carpentry principles. The village of Ironbridge grew up around the crossing. New industrial wonders like the Newcomen steam engine and the Ironbridge were tourist attractions. Artist Philip James de Loutherbourg painted Coalbrookdale by Night, now in London's Science Museum, in 1801, capturing the flames of the iron furnaces, which would have burned all night, and smoke spouting chimneys. On a painting tour of England in 1797, J.M.W. Turner was inspired by industrial scenes. In this small oil-on panel, now in the Yale collection, a lime kiln at Coalbrookdale, Turner chose to paint the scene at night to depict the effect of the furnace. The Coalbrookdale Company was subject to links with other companies and became part of Allied Iron Founders in 1929. Takeovers followed. The foundry at Coalbrookdale eventually closed in 2017. A memorial Newcomen engine from around 1725 has been preserved at Dartmouth and is now operated hydraulically. A restored Newcomen engine can be seen in its original position at the former Elsecar New Colliery beside Elsecar Heritage Centre in South Yorkshire. The Ironbridge Gorge Museum Trust, based at Coalbrookdale, administers 10 Ironbridge Gorge museums, now part of a World Heritage Site, including Coalbrookdale Museum of Iron. Once Thomas Savery's patent expired, others began experimenting with the design. Newcomen's engine still wasn't particularly efficient. The cylinder had to be heated and cooled with each single stroke. Large amounts of coal were required, and most of the steam generated was wasted. The man who made the improvements necessary to really power the Industrial Revolution was James Watt, and he will be my subject next time. If you've enjoyed this video, hit the like and subscribe buttons and click on the notification bell to be informed when the next video is available, or you can subscribe by clicking on the rose window over my shoulder.